Yes, it is. Alrighty. Let's go over the answers to that 2017 mock. Cool. Ooh, let me also get that document camera going so that way you guys can see the question itself. I think that first one was hopefully pretty straightforward. This one was just identifying your functional groups. When I marked this for my other class, I noticed a lot of them struggled with 1 and 2 because they just overthought it. Those are both amines. So just watch out for silly things like that. That one's an amide, and then that was your carboxylic acid. So that should be hopefully an easy point. And then the next one was just your practicing of the naming and drawing. Do you want me to go through any of those? Are you guys okay? And I'll just put the answers on the board so you guys can see it. Guessing by the lack of response, you guys are okay. Here we go. 2 out of 4 for that achieve point. 2 out of 3 for that achieve point. I think those are pretty straightforward. The next question on there was looking at your chiral carbons and doing optical isomers. Keep in mind that with these guys here, what did I want to say about this? I remember. Oh, it doesn't matter what order you guys put these guys in, so long as whatever you draw on the other side is the flip mirror image of it. They've done it in a very strange way, in my opinion. I don't really like how they've done that. The simpler way is just kind of keep that as a straight line and then just draw that guy. I don't know why they've done that. It's very confusing. All right. Cool. I might go back to this. Are you guys okay with that? Do you need me to go over any of that in more detail? No? All right. This one here was just you're explaining the optical isomers. Be really mindful when you're talking about their physical properties. It's worthwhile, even if the question doesn't ask it, just to mention that their physical properties will be exactly the same, the chemical reactions sort of stuff. The only thing that changes is how they rotate in polarized light. Some things to make sure you drop as your key kind of vocabulary words. I might do this in a purple color. I want you to write down things like it's a mirror image. Non-superimposable is another one. Those are kind of key words they're going to look for, so it's worthwhile dropping those. What else was there that they usually ask? Just also be mindful when you're talking about their rotation and plane polarized light that you're just referring to them being in opposite directions. So one's clockwise, one's counterclockwise. Cool? I'm just being mindful because sometimes that question's really, really weird with how they distribute the points and like it's achieved and it's merit. Or usually it goes up to merit level. And sometimes for part of that requirement for merit is that you have all those key vocabulary words down. So just make sure you're putting them down just in case. We good with those? All right. Next question here was on discussing the details of how you would distinguish the two products of the oxidation of glycerol, description of any tests, description of any observations. A lot of people got stumped on this because they were so overwhelmed with these two products because there's so many different functional groups there, and they saw that it had alcohols and it had carbonyls. The thing you have to remember about this question, and what you're also very careful about when it comes to picking your reagents. So yes, they both have alcohols. The key difference is that one is an aldehyde and one is a ketone. So we want to specifically test for the aldehyde. There's no point in me testing for the alcohols because they both have alcohols. The other thing to remember about this is that your normal oxidants that you would use to test, such as the dichromate or the permanganate, both of those do not work for this. Why is that? Because there's alcohol present. So I won't be able to use that as an identification test because both of them are going to turn positive. So you need to be really careful with this question because you could have only used things like Benedict's solution and Toland's reagent. Fellings is the other one. So just watch out for that because that would have been a silly way to lose some points. So let's just look at the marking schedule. So you see what I'm saying here on the marking schedule? There is nothing in here about using dichromate or permanganate because it wouldn't have worked as a distinguishing test. So if you have that down, you're automatically wrong. So just kind of watch out for that. But they gave you free range. You could use any of them. Just state the observation and just be mindful that you know the second one doesn't have a reaction because it's a ketone. Be, again, really careful because some of you guys might have just only written about the aldehyde. You need it to state that the ketone does not react as part of your points. So that's the whole idea, like distinguish between the two products and making sure you have the observations for both. Say or imply the ketone does not react. You wouldn't be able to get the excellence point if you forgot about your ketone. Are we okay with that one? Yeah, I figure that one's not too bad. This isn't too nasty as an organic question, I don't think. Cool. The last one here was about joining your amino acids. I'll go over this one because I know some of you guys struggled with that. Be mindful that with this amino acid question, they often ask you to do it twice because they want you to draw both dipeptides. With that, all you are doing is drawing the exact same thing around. You are just moving and swapping the R groups. Remember that the sequence of how you put these amino acids changes what it is. So it's really important. Let me just grab and just do the answer for you guys. So what we're looking for when it comes to the R groups is carboxylic acid, amine, and amine, hydrogen, hydrogen. Those should be the same on both of the amino acids. So when I say R groups, I'm talking about things like that and that. That is the distinguishing factor, and that's what makes it each its own amino acid. Are you okay with that so far? All right. If I just want to make my life easy, we can just write down the general way of how to link them together, and then just put the R groups down as your last step. Yeah? So do kind of keep in mind that when we're joining together amino acids, you need to have an amide bond. So we need to have your carbonyl, your nitrogen, and your hydrogen. So that is your amide bond. Yeah? So amide bond, or you can say link, whichever. I'm not fussed. They often ask you to circle it as part of the question. So I would always drop that guy down first. The next thing that I would then probably do is I would just put down the generic things that I know are in all of my dipeptides amino acids. So I know there needs to be a carbon. I know there needs to be a hydrogen. And then my next thing to think about is, okay, I need to make sure all of these molecules have a carboxylic acid component and an amine component. In this first amino acid here, it has a carboxylic acid component. So what it means is that the other thing I put down is your amine. Are we okay with that? This guy over here has the amine, so I need to put the carboxylic acid on that end. Okay? So that's something to check. This is a dipeptide. It is not a polymer, so I want to end them. I don't want to do those square brackets in the end because it's not a repeating polymer in that sense. Because with these amino acids, because that R group is different, it's not like a traditional polymer of repeated same units. It's repeated, but the R group changes. So, last step then is I would put down my R groups. Doesn't really matter because I don't think they've given me any instructions. Draw 2 amino acids shown below, one possible dipeptide, so it doesn't matter which R group you put first. So I'm just going to do this one first because he's just on the right. CH3, and then that one is CH2OH. Cool? If you did it the other way around, it's fine. All right? Often with this question, what they will ask you to do is draw both dipeptides. So if I was to draw the second dipeptide, all you're going to do is swap the R groups around. This skeleton stays the same. Does that make sense? All right? I don't want you to accidentally swap and then swap again, and then you still actually have the same dipeptide. So what makes this dipeptide unique is that in this instance, the alanine has the amine group free, and the serine has the carboxylic acid group free. If I swap these two functional groups around, now the alanine would have the carboxylic acid group free, and the serine would have the amine free. Does that make sense to you guys? So it's often a question just drawing your amino acids. But make sure you know how to link them together. Any questions about that? That's basically all of that second question. I'll put up the full marking schedule so you guys can see how the points broke down. So yeah, they had both of them listed. Shows correct linkage, but not the correct structure. Shows one correct dipeptide. Here's how the points broke down. So there are 2 excellence points. The first excellence point was in this bit here, that distinguishing test. And the second excellence point was surprisingly in the optical isomer section, which is usually not where it is, but it was there. So yeah, it was actually a pretty easy excellence point as well, I would say. All right, cool. That's everything. You guys have about 7 minutes to work, so please keep getting stuff done. Drop things in my box. I will try to mark it and give it to you guys back before your exam on Thursday. I'll just email it to you because obviously I'm not going to see you guys in person because you're doing mocks. What else did I want to say? Trying to think. I think that was it. Oh, do you guys know where you're going on Thursday for chemistry? Because you're not in here. No? Okay, let me pull that up for you guys. Yeah, go for it.